The next series test that we're going to look at is the alternating series test. And the alternating series test is set up the following way. You've got -1 to the n minus 1 power, so your exponent is alternating between the odds and evens, giving us this alternating sign here. So then we've got the b sub n term, and we have to have this satisfying the following conditions. The next term in the series has to be smaller than the previous term, and the limit of the terms has to approach 0. If it meets these two conditions, then the series is convergent. So it's pretty straightforward. Meet the conditions, and then we're done. So we're going to look at the alternating harmonic series. So we know from previous examples that the harmonic series is divergent. So what about if we allow the signs to alternate as we do here? Well, looking at the n plus 1 term, adding any values to the denominator is going to make this fraction smaller than the previous one. So the n plus 1 term is smaller than the nth term. And then if we take the limit as n approaches infinity, notice the b sub n is just this part without the sign alternating signs. So if you write like this, you've got a -1 to the n minus 1 times 1 over n. So this part is the b sub n term. That is obviously approaching 0 as n approaches infinity. So that one is convergent. Okay, if we look at this second example, and determine if it's an alternating series. Yes, it is an alternating series. Is it okay that the exponent here is just n and not n minus 1? That's fine. If you wanted, you could break up this into -1 times -1 and -1 like that if you want, but that's not a big deal. So then the question is 3n over 4 minus 1, is that decreasing? Maybe, but it's easier to tell that this limit as n approaches infinity is not 0. So I think that's pretty clear. We've done a bunch of these types of problems. If you multiply the numerator and the denominator by 1 over n, what you get is 3 over 4 minus 1 over n, and that limit goes to 3/4. So there's no point in checking the other condition to see whether or not it's decreasing. Next one, we need to determine whether or not we have convergence or divergence. Again, this exponent isn't n minus 1, but that doesn't matter because we could rewrite it as -1 squared times -1 to the n minus 1. -1 squared is +1, so they're just trying to mess with you a little bit there. We need to determine whether or not this is a decreasing sequence and also whether or not the limit approaches 0. It's pretty obvious that the limit as n approaches infinity of n squared over n cubed plus 1 approaches 0, since if you multiply the top and the bottom by n squared, or actually even n cubed, you've got the limit as n approaches infinity of 1 over n over 1 plus 1 over n cubed, and that goes to 0. So usually condition 2 is the one I'm going to start with since it's easier to check, and if it fails, I don't have to keep going. And what about condition 1? Is n squared over n cubed plus 1 greater than n plus 1 squared over n plus 1 cubed plus 1. So we can try to solve this. We can proceed to clear the fractions and try to collect like terms and determine whether or not we end up with a true statement, but it's pretty long and tedious. You end up with something that looks like this, which is a pretty big mess, and you can get to a place where you see that it is true, this is true, but an alternative method would be to think about the function x squared over x cubed plus 1. If this is our f of x, then a function that's decreasing is a function that's derivative is negative. So if we consider the derivative, f prime of x, where you're doing the quotient rule, if you remember what that is, it's derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom squared. So here's our derivative. We only care about whether or not this is positive or negative when x is 1 or more, right? We have n is 1 or more. Oh, I forgot my squared here. So then what we have is 2x to the 4 plus 2x minus 3x to the 4 all over something that's positive since it's being squared. So the question is, what does 2x minus x to the 4th look like? Is this greater than 0 or less than 0? Okay, if we factor out an x, is 2 minus x cubed greater than 0 or less than 0 when x is larger than 1. If x is 1, we have a positive number. Okay, but really what we care about is whether or not this series is decreasing towards the end, right? So what about 2? At 2, we end up with a 2 minus 8 is negative times a positive number, still negative. 3 works because you'll see that x cubed is going to overpower that 2 for all values greater than 2, since we're thinking about integer values here. So we can determine that the sequence is negative. I'm sorry, the derivative is negative. So our function is decreasing. That is, our b sub n is decreasing. The limit is approaching 0, and so by the alternating series test, this is convergent.